Hello and welcome. If you have ever wondered what blockchain is but felt lost in a sea of confusing technical terms, you are in the right place. We are going to demystify it together, using simple ideas and stories. So, let us start with the most basic question: what is it, really? Forget the word blockchain for a moment. Instead, think of something very familiar: a ledger. Imagine a giant, shared notebook that everyone in the world can see and write in. This notebook records transactions, like when Alice sends $10 to Bob. Every time someone sends money, a new line is written in this notebook for everyone to see. This is the core idea. A blockchain is essentially a digital, public ledger. But why do we need a public ledger? Imagine if only your bank kept your transaction records. You have to trust that the bank is honest, secure, and will not make mistakes. A public ledger removes the need for a single, powerful middleman. No single person or company owns it. It is maintained by a vast network of computers all over the world. This is what we mean by decentralized. Now, let us talk about the name. Why is it called a blockchain? The blocks are just pages from our digital ledger. Instead of writing one transaction at a time, we collect a bunch of transactions over a short period, say, 10 minutes, and write them all down on a single page. That page is a block. Once a page is full, we do something very clever. We take a unique fingerprint of that page, called a hash, and we also write the fingerprint of the previous page at the top of the new one. This is the chain. By linking each new block to the one before it with these fingerprints, we create a chain of blocks, a blockchain. If you try to go back and change a transaction on an old page, its fingerprint would change completely. This would break the chain because the next page would still have the old fingerprint, making the tampering obvious to everyone. This simple linking mechanism is what makes a blockchain so secure and trustworthy. It is a timeline of records that is practically impossible to alter. So, we have this public ledger, this chain of blocks. But how can we trust it? How do we know that someone will not just write a fake transaction, like, "The moon sends me $1 million"? This is where the true magic of blockchain happens. It creates trust without needing to trust any single person. Let us go back to our notebook analogy. Who gets to write in this sacred, public notebook? In a traditional system, it would be a king or a bank. In the blockchain world, it is everyone and no one. It is a network of volunteers, often called miners or validators. These are people running powerful computers whose job is to collect new transactions, verify they are legitimate, and bundle them into a new block. But with so many volunteers, how do we decide who gets to add the next block to the chain? What stops everyone from writing their own version at the same time? The blockchain uses a special consensus mechanism, a fancy term for an agreement system. The most famous one is called proof of work. Think of it as a very difficult, global math puzzle. All the volunteers in the network compete to solve this puzzle. It is not a puzzle that requires intelligence, it requires brute computing force, trillions of guesses per second. The first computer to solve the puzzle shouts out to the entire network, "Hey! I found the solution. Here is the new block." The other computers quickly check the solution, verify all the transactions inside the block, and if everything is correct, they all agree to add this new block to their own copy of the ledger. This process is the heart of the system. Because solving the puzzle is incredibly hard and expensive, it uses a lot of electricity, but checking the answer is easy, it makes cheating unprofitable. A bad actor would need more computing power than the rest of the honest network combined to force through a fraudulent block. This agreement protocol is what keeps the entire system synchronized, honest, and secure, creating a single source of truth that everyone can trust. Now that we understand the ledger and the agreement system, let us walk through what actually happens when you, let us call you Sarah, Want to send some digital currency to your friend, Tom. First, you create a transaction. Using a digital wallet on your phone or computer, you enter Tom's unique digital address, which is like his bank account number, and the amount you want to send. You then press send. But unlike a bank transfer that goes directly to the bank, your transaction is broadcast to the entire, vast peer-to-peer network of computers we talked about. It is like you are standing in a giant town square and announcing, "I, Sarah, am giving 5 units to Tom." Your announcement is now floating around the network, waiting to be processed. The volunteers, the miners, see your transaction, along with thousands of others from people all over the world. But they do not just blindly accept it. They do a quick check. They look into the public ledger to confirm that you actually have 5 units to send. They check your transaction history to ensure you have not already spent that same money elsewhere. This prevents the double spending problem, which is a huge issue for digital cash. Once the miners verify that your transaction is valid, they add it to a pool of other pending, verified transactions. Now, the race begins. Miners start gathering these transactions, including yours, and assembling them into a candidate block. They then start working on the difficult proof-of-work puzzle for that block. This process can take about 10 minutes. You and Tom are waiting. Finally, a miner somewhere in the world finds the solution. They broadcast the new block to the network. The other miners confirm the solution and the validity of every transaction inside, including yours. Once a majority agrees, the new block is permanently added to the blockchain. Your transaction is no longer just a pending announcement, it is now an immutable part of the official historical record. You receive a confirmation, and Tom sees the funds in his wallet. The transfer is complete. We have mentioned that the blockchain is secure and that transactions cannot be changed. But why is that? What stops a powerful hacker or a greedy government from just going back and rewriting history? The answer lies in 3 powerful concepts: cryptography, decentralization, and incentives. First, cryptography, the fingerprints we talked about, known as hashes. Every block has a unique cryptographic hash, a long string of numbers and letters that is generated based on the data inside the block. If you change even a single comma in a transaction, the hash of that block changes completely. Remember, each block also contains the hash of the previous block. So, if you change block 5, its fingerprint changes, which means the previous hash recorded in block 6 is now wrong. This breaks the chain. To cover your tracks, you would have to recalculate the proof-of-work puzzle for block 5, and then for block 6, and then for block 7, and so on, all the way to the very latest block. This leads to the second point, decentralization. The blockchain is not stored on one computer. It is distributed across thousands, even millions of computers worldwide. To successfully rewrite history, a hacker would not need to change one copy of the ledger. They would need to change more than half of all the copies at the same time, and do it faster than the honest network can add new, valid blocks. This is called a 51% attack, and for a large network like Bitcoin, it is practically impossible and astronomically expensive. It is like trying to change the plot of a book that has already been printed and sold in 10 million libraries around the world simultaneously. Finally, incentives. The system is designed to make honesty the most profitable strategy. Miners spend real money on electricity and hardware. They are rewarded with new cryptocurrency for correctly adding a block. If they try to cheat and the network rejects their block, they lose the reward and waste all that electricity. It is a huge financial incentive to play by the rules. This combination of technological security and economic incentive creates what we call immutability, the idea that once something is on the blockchain, it is there forever, unchangeable. So far, we have mostly talked about blockchain in the context of money and Bitcoin. But the technology is much bigger than that. The real revolution is the ability to create trust in any system without a central authority. Let us explore some mind-blowing possibilities. Think about voting. What if we could vote from our phones, with absolute certainty that our vote was counted correctly and cannot be tampered with? A blockchain-based voting system would provide a transparent, public ledger of all votes cast. Anyone could audit the results, but individual votes could remain private through cryptography. This could dramatically increase trust in electoral processes. Consider supply chains. When you buy organic strawberries from another country, how can you be sure they are truly organic? With a blockchain, every step of the journey, from the farm, to the washer, to the shipper, to the grocery store, can be recorded on an immutable ledger. You could simply scan a QR code on the package and see the entire, trustworthy history of the product you are about to buy. The world of digital art has been revolutionized by NFTs, or non-fungible tokens. An NFT is essentially a unique certificate of ownership stored on a blockchain. For the first time, digital artists can sell verifiably unique, original versions of their work, much like a physical painting. The blockchain proves who owns it and its entire provenance. Even our identities could live on the blockchain. Instead of having 100 different passwords for 100 different websites, you could have a self-sovereign identity. You would control a digital ID on the blockchain that you could use to log in anywhere, without handing your personal data over to a big tech company that might sell it. The core idea is this: blockchain provides a foundation for truth. It is a machine for creating trust. In a world overflowing with misinformation and centralized control, this technology offers a new way to organize ourselves, to trade, to create, and to interact, built on a platform of transparency and mathematical certainty. It is not just a new kind of internet money, it is a new layer for the internet itself, and we are only just beginning to discover its potential.